All right. We're good? All right. Hi, everyone. I'm not Shaveen, obviously. Hopefully that's obvious. If not, you're in trouble. My name's Jake Renzella. I know I taught a couple of you in 1511. Did I teach anyone else? Just you? Or you as well? T2 last year?
Yes.
Or maybe earlier? Great. Well, good to see some of you back, a lot of you back. It's not good to see so many empty chairs, but maybe we can change that by Thursday. Great energy in the room. All right, I'm really excited to be back. So I taught 1511 last year in term 2, which is where some of you know me from. But actually, like I said in my email this morning, the first thing I taught when I came to UNSW was software engineering. And the closest thing I am to an industry role would be software engineer, as a software engineer. So I'm really, really excited to be back and talking about some of this content. The course has changed a lot since I last taught it. It used to be in Python, but none of the concepts have changed really at all. So it'll be exciting for me to take a fresh take at some of this stuff. What else should we say? I'm not the best person to talk to specific details about, say, assignment specs because I'm lecturing, not the lecturer in charge. So your tutors, the forum, Shaveen is still the best person to ask about the general course management and infrastructure and things like that, right? But you can ask me any software engineering question you like. Does that delineation make sense? And I'm here for about half the term, so for the next 4-5 weeks or something like that. I think the calendar is up. So I have the best job in the world because I don't have to do the extraordinarily difficult task of administrating a course. That's Shaveen's job still. But I get to come in and just give a lecture and have fun and talk about some of the most interesting and relevant work in software engineering. Cool? All right. Shall we just get into it? Okay, so where's the best place for me to look? I guess here. Now, from the quick look I've had so far, you've done introduction to a bit of TypeScript stuff. You've looked at GitLab. This course is fantastic because you're actually using Git very early. Git is one of the most fundamental software engineering tools. You will use it for the rest of your career, I promise, despite what everyone tells you about the threats of AI. So yeah, you've done a bit of GitLab stuff. You've looked at CI, CD, runners, right? This is all ringing some bells. Today, we're talking about, actually, I think, the reason why TypeScript is the most used programming language today. And or maybe JavaScript, TypeScript if we bundle them together. Someone might want to fact check me on that. In fact, while I'm doing the next 5 minutes, someone should fact check me and yell it back. But I'm pretty sure JavaScript is now #1. So this is kind of like a crazy thing if you've been around software engineering for a while, because JavaScript is like a very broken language. And it makes very little sense as to why it's the #1 language today. But actually, these slides will explain why. Okay? Does that sound interesting to explore?
Someone's got a question asking if the slides have been uploaded yet.
What a good question. And I don't know. So I said, yeah. Maybe, do you want to ping like Rani or Shaveen and ask? I'm just using the slides that were given, so they can just go straight up. Cool. Okay, so these slides are important because these concepts are important, but it also motivates why JavaScript is where it is today and how it got here. So it's basically networking and web servers that we're talking about. So gone are the days of 1511, right? I'm sure you've already spoken about this, where you wrote programs that ran on your machine. Okay? That's what we did in 1511. We ran wrote C language that compiled into an executable that you invoked on your environment. Okay, and that's fantastic, but also so boring, because what fun is a program that lives in its own environment and can't do anything? And so with the introduction of the internet, we had this challenge or this problem, which is if I've got a program and you've got a program, can they talk to each other? How do we get these machines to talk to each other? And I don't mean send an email. I mean, how do we have programs that live across many machines? And it's such an interesting and relevant thing to think about. And I really think we take it all for granted way, 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 way too much. And it's really non-obvious. Anyway, so we're talking about networks. We can't communicate over the internet without networking and protocols and things like that. Express servers, which is one of the dominant, it's probably the dominant framework for creating servers in Node, in TypeScript, in JavaScript. APIs, you've probably heard that term a million times, but what does it actually mean? And CRUD, again, similar. You've probably heard the term a million times. What does it mean? So we had computers for a long time. They're really cool things. Then we got networks. Early networks were local only. So if I had 5 computers in a room, can I hook them up and send messages to them? Okay, then we grew the networks internationally, and so we got the internet, the international network. Does anyone know why the internet was created and who created it? Yeah, that's right. So I really hate, my pet peeve in this room is when this door opens. Maybe I need to nominate someone here to keep an eye on that door. That would be good. Yeah, the DARPA created the internet, which is the research and technology arm of the US Defense Force. And actually, so the DARPANet became the internet, is my understanding. So we needed this way of sending information across networks. And then, on top of the internet, we built the World Wide Web, which is this idea of, okay, if I've got these machines, they're interconnected on the internet, which is a big network. But as a user, what does that experience look like? I mean, I'm not going to type ones and zeros into a protocol and send a message that way. I want a nice presentation of a way to remember your server's IP address and your server's IP address, and that's the World Wide Web, which was invented by Tim Berners-Lee. He's all over the place now, and it seems like all these old tech souls are just getting into politics and things, but he's talking and doing lots of stuff there. So this was this idea that actually let's put documents on the internet and let me have a way to retrieve those documents and view them, which is the fundamental probably one of the fundamental things that most people use the internet for, but the internet is doing lots and lots and lots of different things behind and aside from the World Wide Web. Does that delineation of concepts, the pointer's back, make sense to people? Do we have any questions? It is important to understand this stuff, okay? Because it falls apart when you start trying to do stuff. Yeah, this is not a networking class. I'm not here to teach you how that works. Honestly, networking is one of my least favorite computer science topics. I kind of didn't like it as a student, and I don't understand it now. They're like magicians. They work in their own area. There's usually whole departments of networking. They are computer scientists, but I don't understand them, and they probably don't understand me. So if you really want to understand networks, you can go take COMP1531. We just assume that all the networking stuff works. And like, it's like when we write C programs in 1511, we assume that the hardware works. It's that same kind of idea. I can't actually explain to you how the networking software works. They do literally magical stuff like making sure quantum interference from the gravity doesn't affect bit orders and things. It's nuts. And then, of course, there's hardware stuff, and we don't want to deal with hardware stuff. But we have these networks. We want to send messages over these networks, right? And I need to make sure that if I send you a message over the network, you can understand that message. And if I'm just sending a stream of zeros and ones, without a structure, that's meaningless, right? So it's just like me sending some written language that you don't speak or you've never heard of. That information is completely useless. And zeros and ones could represent anything. I could be trying to send you an image. I could be sending you English ASCII representations in binary. I could be sending you anything. So how do you know, or a client or a server on the network, how can it understand what the message actually is? And so that's where our network protocols come into play. So it's a defined agreement or a defined structure for the messages that we send over the network. Yeah, and humans have protocols. So English is a protocol, right? We've agreed via training and learnt behaviors and when our parents spoke to us when we were young or whoever it was that raised us, that the English language has a certain structure, and if you speak other languages, that's a different protocol, there's different structures. And so we both agree that, if I'm speaking English, you're going to pick up on it. The difference is, I'm speaking English, why? Sorry? Yeah, you know it, but you're inferring that I'm speaking English. I mean, I could be telling you I'm speaking Jake-glish or something, And unless there's a very minute detail that you don't know the difference, I'm not wrong. But that's different to network protocols where we have to explicitly tell each other. So it's as if I got up to the start of this lecture and I said, I'm Jake Renzel and I'm going to be speaking English. And then you'll go, okay, English mode, which maybe isn't a bad thing to do. Also, I've read some of your emails. I'm not convinced all of you speak English, so maybe we should be more clear. So we wanted to define the structures and protocols and declare them when we send these messages. And there's different protocols for different, optimized for different tasks. We kind of see this in verbal language. I don't know, who speaks a second language? Is there something in that language that's very hard or clumsy to express in English? Keep your hand up if that's true. Yeah, and it's the same thing with these protocols. You could explain the same thing in either language if you speak it proficiently enough, but some languages are just evolved and optimized over time to be very good at a particular type of thing, and it's the same with these protocols. Is there a question?
No. So
oh.
They're saying, did you make any changes to the slide?
No.
Okay.
Great. Okay, so here are some protocols, 8 popular ones. I think there's many protocols now. By far, we're mostly interested with HTTP and HTTPS. I'm going to be super honest, I don't know what we use HTTP3 for. Apparently IoT and virtual reality, which makes sense because they're both fields that I'm not super involved in. But I imagine it's, I think I've heard of Quick. I think it came from maybe Google, but it's probably some optimizations over HTTP for higher bandwidth messaging. But HTTP and HTTPS, they're the two that we're talking about in this series. And I would say it's the most general purpose protocol for sending messages over the internet. WebSockets are super, super, super cool. I love using WebSockets. Does anyone know what they are? You use them every single day. So if you ever open up, what messaging app does everyone use? Discord. How does Discord know that you get a message when someone sends it? It's using a WebSocket. So it's subscribed to some server that tells it when it's got a new message to be read. This was actually kind of clumsy and difficult to do with HTTP because of how that protocol is structured. We can talk about it with more detail. TCP, UDP, they're very common. SMTP is for sending emails, or maybe old school emails. And FTP, people probably don't use it anymore, but it was the file transfer protocol. It was very good at, if you want to send a bunch of files to a remote server, it was efficient at doing that. But basically, these are just different languages of protocols that are efficient and designed for doing different things. More recently, as the internet got much, much more rich and multimedia and high bandwidth, we have specialized protocols like WebSockets that are very good at particular types of things that were very inefficient in, say, HTTP. No, not now. But she can ask Shaveen. Oh, rip. Yes, send them to Rani. Oh, that's really amazing. Sorry about this, everyone. Okay, I sent them. Any questions on protocols? You've heard of some of these things before, but maybe we didn't sort of fully appreciate or understand them. Okay, yeah, so we're going to talk about HTTP. It has to be the earliest protocol. Maybe not. Again, can someone fact check me? I need a fact checker. Who wants to be my fact checker this lecture? Fantastic. Okay. If it's not the oldest, it's certainly among the earliest protocols. Hypertext transfer protocol. So hypertext was this term that came from HTML, hypertext markup language, HTML. So all the HTML browsers in that language, that's hypertext we call it. Why is it hypertext? It's text but hyper because it's got links in it, it's got images in it, etc. Okay, and so what we needed was a way to send HTML pages over the internet, over the network. And so we had the hypertext transfer protocol. All right, does that make sense? So think very, very simply, I've got a computer, you've got a computer, I want to send you my web page because you want to view it. we need a way, an agreement, that if I send you the HTML, you know how to unpack it after it goes down the wire. Is that really simple? It's really simple. Well, it's not simple. None of it's simple, but it's simple if you like roll the window calendars back and you think simply. It's simple. This is the origin of the internet and of web browsers. This is all they were designed to do. There was no interactivity. You got to understand that. It was a web page with some text. Maybe you could change the color of the text and links. That was it. And so we just needed a way to send those pages to and from each other. Why are there two arrows here? So the server can see who accessed it? No, well, maybe, but not really. Is that a hand or a stretch?
A bit of both.
It's a timid hand.
So like the web server can send it over to someone?
Yeah, but why are there two arrows? That explains the purple arrow.
So you can upload and download, right?
No. See, that's wrong.
Oh, okay.
Okay, because remember, this is old internet. You're the server, I'm the viewer. There's no idea about uploading. So I can't upload yet. So what are we doing? Like a handshake? Yeah, there's a simpler way to say it. Did you have a hand? It's just the request and the response. Okay? The server needs to know that someone's asking to view this web page or this HTML file. And then the server needs a mechanism to send that file back. There is no idea of uploading yet if we're winding back the clock. And that's where we get this very simple concept of request response, which technically you could call it handshake, but handshake has a specific meaning in some of these protocols, so it's probably best to not use it. Okay, request response. It's super simple. Now, this alone should illustrate to you why the WebSocket protocol was required. Can someone logic out why this doesn't work for messaging? So yeah, there's the upload problem, because you need to send the message up, but put that aside for now.
Because the server cannot actively send messages.
Yes, that's the answer. The server gets, let's say you're the server, I'm user A, you're user B, and we're sending messages to each other via the server. I say to the server, hey, do I have any, I would have to ask the server if I have any new messages. And I would have to do that over and over just to find out if my friend had sent me a message. This is called polling, and it was the only way to do message services on HTTP. But do you see why it's so inefficient? He might have like left the country and he'll never send me a message again, and I have to ask you, if I want to check if there's new messages, every 30 seconds? I'd have to ask you every 30 seconds. And now you're busy answering, none of it makes sense. So you can see why we have new protocols that came out because of this fundamental design. But this is, we've got to go back to the 90s and the 2000s. There was no messaging apps, all right? It was like, you want to view my, I Love Otters website with all my information about the Lutra species of, animals. Do you see what I mean? It was just like, you want to read something. Okay, this might be a slow lecture. I might need to hurry up. I'm having too much fun. Okay, this is the end of the sort of protocol stuff. Is there any questions so far? Is it making sense? Is it interesting? Okay, oh well, we'll keep going. All right, so this is all theoretical and conceptual. How do we turn our machines into these servers and clients? And more importantly, how do we do it today? And how do we do it in a modern framework or language? So back in this era, we were writing these servers and clients basically in C. If you've ever has anyone ever tried writing low-level networking code in C? There's a reason why no one put their hand up. It's a bit of a disaster. It's very difficult. And I said earlier that this lecture might go to some length in explaining why JavaScript has gotten to where it has today, and it's because it's very good at these client-server frameworks. In fact, it kind of makes sense because that's what the language was designed for. JavaScript was designed to be the language that sits in the browser. So it's one of the earliest, or it actually is the first web native programming language. And so with the explosion of the market of just dollars in web technologies, right, it makes sense that all these startups and companies, look at Google, was one of the foundational companies built on the internet. Well, if you're doing internet things, you want to use languages that have a good understanding of the internet built into them. And so that's why we end up with JavaScript. And there's a very simple and popular library called Express that allows your programs, your JavaScript programs, or your Node programs, to act as web servers. I mean, it's really, really, really cool because what would have taken us months to write a basic server, we can do in 5 lines, 6 lines. So what Express does is allows JavaScript or Node to act as a HTTP server. Making sense? Everything's coming together? So you guys know how to install packages and stuff from the Node package manager, right? You've done this before. So you literally run npm install express. It fetches it from the package manager, downloads the latest version, and we can use the library to create a server, and that's what we're going to do now. But let's not look at this screenshot of code. Let's just jump over to my text editor, which you can all see, right? Yes? And I guess online can see it. How should we do this? Let's start like this. Is the font size okay, and should it be light mode, or is this good? It's good? And let me know if it's how it is online, please, Liam. All right, so let's get started with some basic boilerplate code. So we all know the import syntax, right? And I'm genuinely asking because I've just come in this week, but does can someone explain this line? I mean, you read it. So I'm teasing. So we're importing the Express library. Where does it look for to find the library code? Someone said it? Like literally, where is this code? Who said the Express package? Where is it on my computer? Someone said it. You got to speak louder. Node modules, yeah. So you install something, whoops. On npm, you get this node modules directory in the location in which we ran the install command, and it downloads into, there'll be a directory called Express here with the Express library code. And this is where one of the memes come from around JavaScript is like, you have one library and then the node modules directory is absolutely massive, but that's the world that we live in. So we've installed the Express library. Oh, okay, and of course you know how to install it. You just run it in the, npm install Express. You just run it in the directory and it will do that. And if it's already in there, it won't do anything, right? All right. Here's something interesting about servers in general. Remember in our little scenario where you're the server, I'm asking if I've got any messages. I had to ask over and over. Think about now the fact that you're the server, okay? You've got some HTML information, and people are coming to view your server's website. Or, what do you need to be doing, basically? Responding to every incoming request. What does that sound like? I'm kind of stretching it here, but are you doing, okay, is it like a C program we wrote in 1511 where you run the program executes, and the program ends? Doesn't sound like that, does it? So what's happening in this program? Or what's happening if you're acting as a server? It's a function, yeah, but there's something I'm trying to get to that's not as simple. Well, is it a one and done?
Is it like constant polling?
Yeah. The whole thing has to run in a loop. We can't just ask if I've got a request and then process it. We do that over and over and over and over. So when we used to write server code in, say, C, you literally would write a big while loop. And you would say, while there's no incoming new, or while there's a new incoming request, process the request, do this, do that, return some response. But it's really annoying to package everything up into a big loop. And so because all servers run in a loop, Express in JavaScript builds the loop for you. So you don't actually write the loop, but what's really critical is to understand that this is basically all running in a big while loop. And that's what some of this boilerplate code sets up, like this line here. So it says we're creating an app object, which is the result of calling the initialize express function, which is just express with the two brackets. An app is going to be this object, but it's also, you've got to understand that this is now a life cycle. So this program will not end unless I decide to end the program. But that makes total sense because servers never stop working. They always need to be understanding if there's a new request. So they are running on a big loop, which is why your laptop is not a good server, is it? Because we close our laptops when we go for a walk and now they can no longer make requests. So the servers are typically dedicated, optimized hardware. We have a huge server lab over in K17 that run these servers these HTTP servers on large loops. But I just wanted to talk about that because it's not obvious from looking at the code. Okay. Then we have this idea of setting up the port. Now, does everyone have a rough understanding of ports? No?
It's like some hundreds of gates inside your computer.
Yeah, gates. So you just said that it's like we have thousands of gates in our computer. Really simply, imagine without the concept of ports, okay, how many servers could your machine operate? One. Yeah, right. So it's literally like you've got a front door to your house, and someone comes up and they knock on the door and they say, can I have the flyer on otters? And then you hand the flyer through the door, and then they leave, and then the next person comes up and they knock on the door. A port is just like adding a door to your machine. So it's got nothing to do with the server or the program. It's actually at the server level. And really what it allows you to do is run more than one server on different ports. Now, most machines are running maybe tens to hundreds of servers, whether or not you know it. In fact, your Mac laptops, and I'm sure Windows too, but I'm just more familiar with Macs, they're running like secret internal servers all the time. So for example, printing is a server. So the program is running a server, printing is also really a nightmare, complex thing. But there's a bunch of servers that are always running, they're doing system things, they're doing important things. And so what's important to know is that there's a range of ports dedicated for user or user server operations. And there are a lot of them, but typically now for backend systems, they start at 3000. So you can pretty much, if you boot up a fresh server or a fresh laptop, port 3000 onwards will be available. There's probably a great website with available port ranges, but only one server can operate on one port at a time. So if you try to set this up, we can even do this as an experiment, but if I tried to create two servers on port 3000, the second one would not work because that port is dedicated. Okay, making sense? You see ports all the time. Who's ever logged in, now not so much today, but who's ever logged into like a router with the IP address of the router at home, like your 192.168.0.1:3000 or colon something? That's the dedicated port for that IP's web access server, okay? So we do use them in networking all the time. So it's like the IP address gets you to the building, the port gets you to the right door. Got it? Okay, but we need to tell Express, when I'm creating a server, which is what we're doing right now, which port to use. And for backend services, so backend meaning servers, we typically start at 3000, but maybe a 3000 will already be taken. You could just use 3001, for example. I'm pretty sure as well, you could not give a port and it will find the first free port at 3000. But anyway, let's play around with that later. Okay, so far line by line, we're feeling good? All right, what's next? I'm going to consult over here. Okay, then we've got this line, app.useExpress.text, which I got to be fully honest, I don't quite remember the details. I'm assuming what this means is that if I return data from an endpoint, it's going to return as plain text. Do you want to fact check that? Someone just Google what app.useExpress.text means and then yell it back. So I'm pretty sure all this is doing is a bit of configuration to say how to convert, say, from a string in JavaScript. How does that get converted back to the endpoint? I'm guessing the other option here would be like JSON. Yeah, but we can talk more about that in a minute. But someone's going to fact check me. I know it. Okay. All right. Okay, we could find it out together later. All right.
Reading the text data from the
Yeah, so it's just saying that rather than returning, remember what was HTTP designed for? HTML. So I think why this is here is because we're saying I'm not actually going to return HTML yet, I'm just going to return plain text. All right, so we're configuring this app. This app is the Express server. All right, what do we have on our slide? What are we trying to do here? We're just setting up a really simple server. Okay. All right, now, we have to talk about endpoints. So the IP address is the building, the port is the door, okay? Let me think about this. How do I explain this? Again, I'm running this server on Otters, and I've got a website for maybe beginners that don't know anything about Otters. I've got a website for intermediates, and maybe I've got a website for Otter experts, you know, fellow colleagues in the lutrinology field. Maybe I want to return different slightly different web pages or different web pages to the different sort of visitors. So they can give me some detail as to, you know, what level of detail they want, and I can respond back appropriately. And so this is this idea of endpoint. So there can be some data as part of your request that helps me know what you're trying to do at my server, and so I can get you the best possible response. But we both need to understand it. But before we do that, we can just do like the absolute default response. And so remember, app is our server, okay? And we say app, we can say app.get / comma. What's the request object? What's the response object? Whoops. So I'm just going back and forth. Yeah. This is a function which can return response.send otters. All right. So let's break this down. We're saying I want you to register a get endpoint on my server. We'll talk about endpoints and the different ones very soon. Now, what does this mean? You got to speak like 4 times louder. The root. Can you elaborate on that? Do you want to? No? It's correct, yeah. So think about, oh, do we have whiteboard markers? Could you throw one? Think about these HTTP requests as web URLs, right? Thank you so much. So when you typically go to a website, what are you typing into the browser? The URL. So it's the name of the IP address of that machine. It's more complicated than that, but let's just say that for now. But so like I've got the website lutre.com, but this is mapping down to some IP address somewhere with the whole DNS framework, whatever. So remember, this is that building. That's the server. Now, there is actually a port here, but why do you never type in a port when you go to a web server? Yeah, that's exactly right. So we've just all agreed that it would be really annoying to ask users to remember and to enter a port. So we've all agreed that if you're accessing a server and the goal of the user is to access a web page, use the default port, which is 80. Exactly right. So 3000 is for servers, 80 is for web servers. But this is a different type of web server, so let's not worry about that for now. Anyway, okay, so we go to lutre.com, and now that's all I go to. There's no /, there's no anything. Well, there's actually a default /, and that / is this one in the code. So we're just saying, if someone visits my server and that's it, this is what's going to happen. Make sense? And what's going to happen is that I'm going to send a response. And what are we sending? Yeah, we're sending what? Text. Because I told it I'm going to be sending text. Okay, is it all coming together? Okay. I think that's it. I think this is... No, it's not. We need this part. So we never actually... So we defined an endpoint, we set up some components, but we never actually told JavaScript or told Express to start the server. The way we do that is app.listen. And I think what you do is give it... Okay, well, I'm just going to paste this, but you do app.listen. We're passing in, well, what port should it be listening to? Well, it should be the port that we defined at the top of the file, which is the port 3000, right? That's just using the constant there. Do you understand this syntax? You should, hopefully you've got a bit of an understanding. What is this saying? Nameless function? Is that what you're saying? A nameless function, yeah, lambda maybe. But what we're doing is passing to the listen function the port and the function that should run, and what the function should do after the listening starts, which in this case is just a console log to tell us that it ran successfully. And it's going to say what port it's listening on. Okay, that is a full, very, very minimal Express server program. All right, so let's make sure that this works. So how should I start this? Well, how should I run it? Node. Then what? The name of the file, yeah, which is just basic.javascript. Okay, and we get this write line, this print statement that the server is listening on port 3000. Why did it print that out? Because that's what I told it to print out here. I could as easily say Jake's Otter web server starting now, right? I'm going to kill this. And that also gets printed. It gets printed once. Now, is the program ending? Why isn't the program ending? It's looping, that's exactly, beautifully said. It's looping through and waiting until there's a request to process. But did I write a loop? No. So where did the loop live? Somewhere deep within probably app.listen. We probably can't even view the code because the lie that we told you that JavaScript runs everything and everything runs on JavaScript is probably this server is actually written in C++ or something somewhere. So it's actually very hard to find that code. It's very different from say writing C, but probably somewhere within this Express server, when app.listen executes, there's some code that looks very similar to your 1511C code that's like, starts a while loop. While some conditions are not met, just keep running. This will run forever. And it's so heavily tested because so many critical services run on Express that I can assure you, unless this computer malfunctions, this server will truly just run forever. Right? But it's really important to know that just because you didn't write the while loop code yourself, that this is running on a loop. This will just keep running. Okay, so it's running. So, oh my God. What do we do now? So this is a server. It's running some code. There's an endpoint registered, right? The default endpoint. So a user should be able to hit this endpoint and get back that response. So maybe I'm skipping some slides. Maybe we should go back to the slides. We can finish this now and then talk about that. Okay, great. So you know what? I should be able to just do this. I should be able to go to my browser. I should be able to go to localhost. I should be able to go to port 3000. And I should just be able to type a /. I think this will work. Oh my God. Well, you don't have to clap me, but clap the woo. Okay, that's amazing. So this web browser went to this server location. Now, why was it called localhost? Why did I type? Where did that come from? It might be obvious, it might not be. God, this really lit the room up, didn't it? The white web browser. Who answered? Sorry? Yeah, this server is locally hosted at the moment. Now, all that means is this server is not wired up to the internet. It's locally running on this machine. In order to get this server like publicly accessible, it's actually possible. In fact, if we're both on eduroam, and I probably had to take my firewall down for a second, you would be able to type in my machines. You know what? We could probably do it. We could probably do it. Oh, you can't see the. Yes, it is. Oh, okay, okay. I went to this URL for those online. Sorry, Liam's just saying online. I guess they can only see the contents of the browser. So I just went to that URL. Okay, so I think this might actually be possible. So, okay, this is probably really silly, but let's do it. Okay. No, it should be fine. Well, so you should be able to go to your browser and type that instead of localhost :3000 /. Maybe there could be a firewall here. Does it work? Did it work? Do you see otters?
No, I think I cannot ping you.
No, okay, something, yeah. Maybe eduroam's a very complicated network, and it might be doing, Yeah, it's either a firewall thing or the network's more complicated than a standard home network, which is definitely true. Okay, whatever. We can figure that out another time. All right. But are you following along, by the way? Were you able to get the demo working? No one's following along. Guys, you did? It was working? I mean, that's really cool. Like, what we did here is you created a web server in JavaScript using Express. You used your browser as a client, and your browser went over an internal network, a real network, in the machine, used the HTTP protocol, hit that endpoint. That endpoint got matched to this endpoint route, and processed that it should respond with the text otters. I mean, that is you got to understand. I guess you don't appreciate it, but to do this in like C is. You should try it actually as a fun experiment. Like go and just rebuild this in C. In fact, you can do it with no libraries. It would just be a lot of work. Although now you've all got Claude code, you could do it very simply. Okay. All right, we should continue, hey? Do we have any questions? Are there any questions online? Okay, that sucks, but we can continue. All right. Okay, I guess there is one more thing to talk about here. So that was this idea of having like a default route or the root route. But remember I said that I have this idea where I might have beginners, intermediates, and experts, right? So I can have different routes. And so basically all I would do is change the route. Okay, so now I've got this default route. So if you come to my server and you knock on the door, you're going to get back the text otters. If you come to my server, you knock on the door and you say, I'm looking for the expert route. Okay, I'm pretty sure the right spelling of the Latin name for the species of otters. Do I have my fact checkers going to check? And if and only if the visitor goes to that route, they will get back that text. And so we can go back to our browser and we can test that. Now, what do I type in here to navigate to that route? Was it expert or experts?
I think it was just expert.
Oh, what did I forget to do? Say it. I've got to rerun it. Yeah. This is just like in 1511 when you forget to recompile your program. Oh, things don't change. So I got to quit the server because the server code updated, but the server that was running had not updated. And I just rerun it again, right? And I go back and I just refresh this page. Did I get fact checked on, is that the correct? Yeah, great, thank you. All right, makes sense. And again, if I remove expert, we get back otters. Okay. What time is it? Oh my God. All right, what are servers used for? They were serving files. We spoke about that many times. Today, they do very different things. And that is true. Very uncommon now for a server just to respond back with, well, it almost never responds back with just some text. It's not even common that a server just responds back with HTML. Why do servers not just respond back with HTML anymore? It's not, yeah, it's too simple. It's not that it's too simple, it's that users we're not building websites anymore. We're building full-blown applications that run on the internet. And so that means that people aren't looking for, I'm not going to make $1 million by creating this Lutra information site. I might need to create like a gacha game where you collect different rarities of otters, right? I think there are 14 species of otters. And so they found a new one last year. Isn't that exciting? So basically, servers are much more content rich. And you're not just returning back HTML. What you're usually doing is returning back a HTML page and then updating information in the page. Think about if you go to messenger.com, the HTML comes down, but what's inside it, that gets updated. All of that, these ideas need to be supported in these servers, and that's what we're going to be looking at. And typically, we use JSON, the JavaScript object notation, to send back this information. You've used JSON a little bit, yeah? If you've got an object in JavaScript, that's a JSON-esque thing. Okay. So we can make our servers respond with JSON. It's very, very, very useful. Okay. Interestingly, if you're really a quick reader, what's missing from this screenshot of code? Yeah, there's something not here that was in the first example that we wrote. Well, I guess it's still there, huh? 11? Line 8. No, line 11. Yeah. Sorry. So we're not returning text anymore. We're actually returning objects. We're returning JSON, which is an interesting question. So what would this server do now? Oh, it does the same thing, I guess. Okay, boring. All right. So the idea here is that we want to give back more structured information. All you really need to know here is that, what is that? Go away. All you really need to know here is that it's just like sending back text, but objects are key value pairs. Why is that useful? Because we send back lots of information now, and without the key value pairs, it's just hard to know what's what. Okay? All right. So, instead of sending back plain text, we send back result.json. So we're going to send back a JSON object. There's probably still a function call here, but we just have an object. Is that what I'm guessing? Correct. Yep. And we return back key value pairs. Okay, so it might be, let's say I'm returning back an otter. So it might be that the species is Lutra, common name is otter. Let's just do a 2 thing for now. They're comma separated because it's an object. That should do it. Let's kill the server, rerun the server. I go back to my browser. I have to type otter because I changed that. Okay. And the web browser actually knows that it's JSON, and it's giving me this object to pretty print the JSON response, which is just to say format it nicely. And we get back, in JavaScript object notation, the data that I returned back from the endpoint. This is, it's got to be like 95% of endpoints on servers right now on the internet return JSON. You can go to any web page, refresh the page, look at the network requests coming in, don't filter for favicons, and you will see, anytime you see this icon, you're probably getting back a JavaScript object. There's one. It's got the key entities, total hits, page stamp. Now, I don't know what any of this means. Why? Because this is an endpoint written by the Kahoot development team that the Kahoot front web page knows how to use. So you load the HTML for the Kahoot page, and it makes further requests to the endpoint. It gets back some objects, and it populates the web page that you see. But this is very, very, very common. Here's a larger object that comes back. Here's an even larger object that comes back. Right? Look how much information. This is just one request on the Kahoot page. Look how large it is. It doesn't even give me, well, that is not 5 lines. It's 74,173 lines of JavaScript object notation came back at this endpoint. Now, maybe the Kahoot people need to learn to optimize their endpoints a little bit, because that's a bit much even for the internet. But really, modern computers, modern networks, you can do silly things like send 74,000 line objects over HTTP. All right. Okay, that's servers responding with data. Do we have any questions? Okay, well now I've got a Kahoot, and if you don't get full marks, it's not going to be good. Okay, so we'll do Kahoot, lecture break, come back, keep going. Sound good? For those of you, you know, that's how I run my lectures. All right, I wrote this morning, and again, you should know, if you've been in my lectures before, I take no liability if there are inaccuracies in the lecture content, in the Kahoot content, sorry. The lecture content should be good. Why did I pick tennis as the background? Because in my mind I was like, HTTP request is like the serve, and then the response comes back as like a return, and then you keep going. Yeah, good chat. Yeah, but they're in my office, so we got to go up to my office after this to collect your prize. Oh yeah, I guess you guys don't know. So my Kahoot's always like back for 1511. I have a Kahoot. The top 3 winners get a Pokemon card from a random selection in my office. Cool. So someone asked, aren't they increasing in value? Not the ones I've got. Okay, they're like the cheapest off-card pack on Amazon that I could find. But maybe. I think someone got a shiny a couple times, but they're probably, I don't know, yeah. All right, tell me when is everyone in? Anyone need a second? Online's good. Remember as well, if you're online, you got to look at your Kahoot screen. Don't look at the live stream because there'll be a delay. All right, I'm starting. There's also some week 3, the first few questions are from week 3. All right. What is the primary purpose of continuous integration? This desk is very dirty. Okay, very good. To automate the integration and testing of code changes. 7 of you said to prevent developers from pushing directly to the master branch. So that's just branch protection settings in GitLab or GitHub or something. So that wouldn't be it. To automatically deploy code to production after every commit. Yeah, that's not continuous integration. That would be what? CD, continuous deployment. Did you not talk about it? Guess not. Okay. Next question. All right, who's decisive bat? Are you in the room? Okay, so I guess that just means you were the quickest so far. But all right, in Express. Oh, I don't know. Have we even done this yet? Nope. Oh, let's just skip it. Oh my God, someone got very lucky then. That's so unfair. Maybe I should do this. Okay, we should do this Kahoot at the end of the lecture. Sorry. I guess in my mind we went through it way faster than we did. Okay, do you want 3 minutes break, or do you want we can also just keep going. Do you need a break? Maybe you're all a bit older now that no, you want a break. Okay, fine. Okay, go have a really quick break. We'll come back and keep going, and I might pick the pace up a bit. And we'll do the code over again at the end. All right. We good? Are we back live? Okay. I think we got to pick up the pace a bit. I'm having way too much fun. We hit some servers with some endpoints. We got some data back. Now the question is, how do we provide data to requests? So it's very common that we do want to provide some data. In fact, we have technically already been doing that a little bit when we have some information in the URL like /otters. I guess that's not sort of data that goes into the request. So we have this idea of queries. Okay, so queries, in fact, we do have the object for queries. Queries come in the request object. So we have the request, we have the response. And queries are extra information, part of the request, that tell the server some guiding information. Like, for example, if I want to, if I've got sort of 14 otter species and I want to query which otter I want information on, I might need the ID of the otter. So that goes into the request query. So in this code, are we getting more familiar with reading Express code? So we have an endpoint called myURL that will sit after the localhost 3000 port. So /my/URL. There's a request and there's a response. And so what we're saying is at this endpoint, there should be a name and an age object or piece of information passed as part of that request. And they live in these query objects. So request.query they live in request.query. We have one called name and we have one called age. And then I can use them as variables, and in this case, it's just sending them straight back. Now, a question for you, well, the answer's down here. We should actually sort of run this. So let's go back here, hide node modules, let's go query. Okay, so this is the code that we just saw on the slide. Let's kill this server, let's run input query. How do I get that information in the request itself is the question. Okay, queries. So queries are great because you can actually put them as information in the URL itself. Okay, what does that mean? So I go localhost 3000. Was it, what was it? My/URL, okay. Then I do a /. Now, we wanted the name and was it age?
Yes.
So I want the name query and the age query. How do I put in the URL? What syntax do URLs use for queries? Does that work? Oh yeah, that should work. I think it'll actually I think it will work as the URL, so that's good. Okay. Okay. So what do I do here? So we use a question mark to indicate we have query parameters, and we use the keys of those objects. So name equals Jake. Now, if we have multiple queries, what do we use? You've probably seen this in many URLs before. Ampersand. And another one is age equals, I don't want you to know my age. You can know my age, I really don't care. Okay, look at that. So those two pieces of text information go into the query. They're called query parameters. Now they are named query parameters. Why? Because there's a key and a value. So the key is name and the key is age. The value is Jake, the value is 99. And in this server, all we're doing is getting the name query out, getting the age query out, and responding back with that data in a JavaScript, in a JSON object. Make sense? We're not actually doing anything with it. Now, query parameters are very, very, very fickle. Why are they fickle? Because user comes along and they misspell name. What happens now? And this question of what should happen is another one of the reasons why JavaScript has won out as a language. Okay, what is that? What do I mean? This is an inappropriate query, okay? Because there is no query parameter named NAM in the code. So why this didn't crash though? Because JavaScript knows it should be a resilient language because users are going to make lots and lots of mistakes. And so we just see that, well, there is no object name in the query parameters, so I have nothing to give back to you, so you have this undefined value. But there was something called age, and you get that back. Does that make sense? You had a hand?
I think that pretty much
I answered it?
my question.
Yeah.
I was going to ask, like, what if you don't put in one of the
Okay, and what happens if you don't have one of these query parameters? Here's the trick. You always need to assume you won't have them. Like the chances of this query being perfectly placed is very, very low. It's very likely that someone will mistype something, a link will be broken, a URL gets malformed, who knows. So your server code needs to be very resilient because if you crash the server, your server stops running, you lose millions of dollars. Okay. So that's a simple way of sending very simple data to the server. Now, can I send lots and lots of data that way?
Yes, you can.
I mean, it's all relative, but probably not. Now, we don't want, sometimes you see extraordinarily long URLs. It's not great. This is it's for query, it's for like little bits of guidance on what I want to be doing. Am I going to send a whole image up in the query URL? In fact, you can do it. It's called base64. You can string encode an image, but it gets too big and it doesn't work. Okay, so simple little guiding query information go in the query parameters. But what if I want to send an object of data, like a large amount of data, like an image, like a bitmap? It doesn't really make sense to be part of the URL. It's not, when the URLs are too long, they're not shareable, they're not useful. The browser's got to, they're a nightmare, okay? But let's say you're uploading an image to Facebook, or I know no one uses Facebook anymore, but you're uploading an image to Discord, I guess, whatever. We've got to send that data via HTTP. Somehow we use the body. So a request has the sort of the URL component, which is what we've been dealing with so far, but it's also got a body. You can attach to it some information. Now, the trick is you can't simulate this type of request in the browser URL. Does that make sense? So these types of requests aren't initiated by visiting a web page. They are initiated by other client programs sending requests to your server. Does that make sense? So you load facebook.com, you want to load an image. What you're really doing, you create a button, you click the button, some JavaScript executes, it grabs the image that you uploaded, packages up a request object and executes the request. So browsers can run this type of request, but not via the URL. So we need some other ways to test these requests and to make these requests. And we need to, actually this is parameters, which is slightly different. I'm going to skip parameters. Because I actually don't really use them much. You shouldn't be aware of them. I don't even know if you use them in the assignment. You might do. Parameters are slightly different. It's more like pattern matching the URL. In reality, I find query parameters are used in much more frequently. So by default, I think use query parameters. These parameters are more like if you have a structure of the URL, you have like a placeholder for the name. Whoops. And so anything that goes there will be associated with the name key. Okay. So far, all of these endpoints have been get endpoints. So I'm getting data from the server. But what we were just talking about, submitting data to the server, it doesn't make sense that if I'm getting data from the server, I'm also sending data to the server. So we need a different type of endpoint. And the other very common type of endpoint, is the second of the four that I think we're talking about today, is the post endpoint. And post means I'm posting data to the server rather than just receiving it. Now this is different from having data in the URL query parameters. That's still a GET request. It's just a bit of like extra information. A POST is like, no, I'm going to give you a serious body of information. If we go back to our code, we have our POST example, which is it not here? Oh, yes it is, I just can't read. They're built exactly the same way, that's really nice. We just use app.post rather than app.get. And this registers this endpoint as a POST request. So data coming to this endpoint /hello, okay, will have data in the request body. This is what I was talking about. We have actual JavaScript data that goes up into the request. So I'm registering an endpoint called hello. I want to get some data from the body. How do I actually test this endpoint? Like I said, right, there's nowhere for me in the browser URL to put body data. Doesn't make sense. So we have two options, or there's many options, but two options for quickly and locally testing POST requests. Does anyone have one off the top of their head? Curl, absolutely. Curl is a very, very, very useful package on Linux machines. So if you type curl into the terminal, it's right, it's a command, a command line executable. And you can put data in the curl command that executes as part of the body. Now, what's the syntax for it? I actually don't remember. Why did that just do that? Oh my God, did Chrome just crash? That's very annoying. Oh, you're kidding. Okay, yeah. How's that? Okay, this looks like this is how you do it. So let's go back to VS Code. Let's add this in. So we're querying localhost via the HTTP protocol. The endpoint was, let me close some of these. Whoops, that's the one I wanted. Was /hello. Okay. We're saying I'm going to be submitting JavaScript object notation content in this request, and the data in this curl request is going to be, what did I want it to be? Name. Name. Let's do Jake. All right, let's see if this works. So basically, so as long as that server's running, which I didn't actually run, the server's running. In another tab, I'm just going to make this request. That didn't work. Why didn't it work? Wrong port. Is that what you were saying? No. I didn't give it the port. So the default port is 80, but this is a server port running on port 3000. All right, well, we got something back here. Didn't like that. Yeah, that is a bit, oh, okay. There must have been when I copied the command, there must have been some character hidden in the copy. Okay, but that's really cool. So what curl did is it made look at that, okay. It made a POST request type to this endpoint. It said, I'm going to be passing in some JSON object, and then the data payload -d was a JSON object with the key name and the value Jake. That triggered the server code. So it matched the post, it matched hello. It looked in the body of the request for a key named name, It found it, it took it out, and it returned it back. Name is Jake. Cool? That's one of the simplest tools to test endpoints available on most machines. Now, you can imagine that building very, very long request parameters in a terminal command can also get troublesome. So there's lots and lots of tools that allow you to test endpoints very quickly. I personally use one called Insomnia. I haven't opened it in ages. God knows what's going to appear. But I think there's a different one that they use in this course, and I can't remember what it's called. But what this lets me do is say, okay, I'm going to hit port 3000. What was it called? Hello? Is that right? And in the body, I want to have a JSON. Oh, yeah. How's that? In the body, now formatting this can be a bit annoying, but I want name to be Jake. There we go. And so these applications are just handy because they let you build very complex test requests in an application with a nice UI. You can save them. You can build multiple out. So useful when you're building endpoints is to test them as you go. Because with these things, it's very difficult. One slightly misnamed character here won't work because it can't pattern match the object keys. Another thing that always gets me, sometimes I forget to change that. That doesn't work at all. Why doesn't this work? There's no get endpoint. So this created a curl request. It's probably using curl in the back end, I'm quite sure. This built a curl request. The URL was right, the endpoint was right, the data was right? Like that'll still not work. But it made a get request, which is a different type of request. Express receives the request and says, sorry, I can't match you to an endpoint. There is no post. There is no get endpoint for this request that matches. It won't work. Can't match it, yeah. Okay. So that is posting data. And this idea of this combination of post and get and endpoints and things, the way we organize these endpoints is what we talk about when we're talking about an API, an application programming interface. API is not a real thing. It's like it doesn't exist. It's just like, how do you know with my endpoints, like logically how I'm thinking about them? That's an API. Or how do you know what endpoints are available? That is the API. And we can write JavaScript code to make these requests as well. And I think the example we're looking at here is one called synchronous requests curl that allows us to programmatically send RESTful API requests. So that lets you write JavaScript code to make those requests, which I suppose is the third obvious answer. So you could use curl, you could use a program, or you could just write JavaScript. So when you write JavaScript tests that test endpoints, you're using something like this. Or you can use one of these clients. I use one called Insomnia. I think it's like one of the industry standards. Advanced REST client, I think, is pre-installed in CEC environments. So you can use that. They're all the same thing. They're really simple. Yeah, this is just running through ARC. I ran it through Insomnia. It transfers very easily. Web servers can make GET requests, but nothing else. Web browsers via the URL only make GET requests. Makes sense, because why were they designed? For you to load a web page and get content. Now, web browsers make all types of requests, but it's driven by the JavaScript running in the applications. Does that make sense? Don't just, did that make sense? Put your hand up. Did that not make sense? I don't know why I ask these binary questions and most people don't put their hand up. Am I going too fast? A bit fast? That's fine. I mean, it's fine. Web browsers always make GET requests. When you navigate to websites using the browser, you click a link, you visit a URL. It's only asking to get some information from the server. That's how, because with early web browsers, that's all they did. You got to think about it as a timeline. And then 10 years went by and you loaded a web page and we had this idea that I want, when I click a button, for extra information to go to the web server. But see, that only happens from within the page itself when I click that button. The browser itself is only still making GET requests. So if I want to test out these POST requests and other types of requests, I have to use either JavaScript code, a client, or curl, or something like that. All right, there are other types of requests. We looked at GET, we looked at POST. There are 4 very common ones, but actually there are a bunch, some of which I'm sure will surprise you and me. But the 4 request types are GET, POST, delete, and I think patch. And what does CRUD stand for? Create, yeah, no, I'm forgetting. It's create, remove, no, it's not. Create, is it read? Update, delete? But they align with the 4 POST HTTP request types. So CRUD is just a more generic version of this. We care about CRUD in lots of things. So like databases have their own version of CRUD. You can read from a database, post information to a database, update a database, or delete something from a database. And so very common for fully featured servers is you're doing all of these things. So we have this server called books. Okay? So if I look at it, here's the first endpoint. How do I know that this is the first endpoint? Well, the first thing my brain does, because I've looked at this type of code way too many times, is I do pattern matching on the braces. So the brace opens here, the brace closes here. This is the post request, the post request. So what's the request type? I just said it. It's a post request. What's the URL or the query parameter? Books. It's not a query parameter. In this case, it's just the query, I suppose, or the endpoint. So you've got to think about it. These are like function signatures back in C, right? There can only be one post request for the URL books. They have to be unique. Now, it has this request object, it has this response object, and it does this anytime that express matches up that request. Now, what does this do? It gets some data from the request body, which means that this is a post. Now, this makes sense, right? All post requests should have some data. Because post specifically means what? You're adding data, you're adding information. So there's got to be some data that comes along with it. So if you see post requests without any data, something's probably wrong. Not necessarily always, though. But now, what did I mention before? You cannot assume all the data is going to be there. Things go wrong with requests all the time. So we do some checks. This is called a guard check. So we're saying, like, I don't want to do anything here unless I know this request came, and it came with a title, an author, and a year. Right? Because we're adding a book here in this case. Then I might have some business logic. Now, this is a really simple endpoint. So I'm capitalizing the book. I do a bunch of things. In real production systems that are meaningful and somewhat large, what's really important is to separate concerns with regards to processing endpoints and processing business logic. So this makes sense to be here to me. This makes sense to be here to me. This stuff, it's like, what am I actually doing when I get a fully formed request should be taken care of in a different component of the system. Now, because we're just teaching you as an introductory, right, this makes sense to put everything here. But very commonly what you'll see is like a helper function, or you'll see something like, books.new add title, author, year. And then like all of this gets sorted out in the call. Does that make sense? But for here, it's completely fine. So we capitalize the title, we create a new book object. We push it to books. Books is just an array in this case, makes sense. And we return back something that tells the requester that this went okay. So I know that was a bit fast, but if you can get your head around what's happening here, you're really getting your head around the backbone of modern web applications. See, get requests are really easy. No information's typically coming. I just want to get all the books. This will get me that list serialized into a JSON object for me to view when I do whatever I want with. Any questions on this file?
When you have like the post and the get request for /books.
Ah, yeah, good question. Oh, you just want to talk about it?
Like which one happens first, or like how they interact?
I want you to answer that. What happens first? You're the server. You've got 2 endpoints registered, so you put 2 hands out. One's the get request, one's the post request. Okay. What is your job as a server? Think about the name. It's in the name, guys. Yeah, but think about it. To serve, yeah, but think about it like only once someone requests something from you do you serve back the response. So what happens first? No. It just depends on who comes and asks you first. So you're thinking about this in too logically. You're registering endpoints here. When this server code runs, does this code run? No, does not run. When does this code run that's highlighted? When you get the matching request, in this case when someone tries to post a book. So what runs first? I don't know. When you run your server and then I come and I say, can I post a book to you? You'll run the post block. So it completely depends on which request comes first. You look confused.
How do you differentiate the two?
Say that more clearly.
Wait, how do you differentiate the 2 requests?
Okay. Yeah, well, your original question was, we've got 2 endpoints, both called books. Maybe that seems confusing. They're different types of endpoints. One's a post, one's a get. In the HTTP protocol, when a request is made, it must have a request type as part of the request. So that's why in curl, in Insomnia, which is this application here, the request type needs to be selected. So the first thing that happens when a request hits your server is the server should pattern match which request is most appropriate. So if it's a request with a get, what's it going to hit?
It's going to go to
What's only going to go to get? It only pattern matches to one endpoint. Okay?
So you mean that I can send different requests to a same endpoint?
Well, they're just different endpoints. These are 2 different endpoints. How many endpoints are here? 2. What's the difference between them? Yeah, they're just different. They're doing different things.
Okay, the one with get is the one you type the URL.
URLs, when you go to Chrome and you enter in a URL, only makes get requests. So it's just putting the get signifier in the request.
But you can't do a post.
Not in the URL.
Yeah.
No.
Makes sense.
It's like, here. It's like get is blue, post is red, and if I'm making a request, I come over to the server and I give you the blue marker. Now you receive that marker and you've got 2 endpoints registered. Which one are you going to run?
Get one.
Why? Because I made a get request.
Yeah.
Throw it back. Does it make sense? I could, if you look in Insomnia here, there's many different types of requests. Just don't overthink it. It's like you're a server and I'm coming up to you and I say, can you give me the books? It's a get request. I'm asking you to give me something. It's just in the request. Actually, it's funny. So the logic for pattern matching requests is very, 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 very complex. The work that Express is doing, because you've got to understand you're taking a string of characters from the URL, let's say, and you've got to decode that into these very complex patterns. And it's not simple, trust me. That's why, again, try and do this in C if you're really brave. I mean, it's just a nightmare. So if you're writing server code, are you saying? How do you have servers, endpoints that do different things? It's all in the request signature. This, I don't know what this does. I minimize the code, right? But this request signature, or this request endpoint, I know it's going to be, it's posting data, and I know it's the books endpoint. If I want to do something else, I just make a new endpoint. Right? Like I made a different endpoint to get the data back. If I want to update a book, so the book's in the database and I'm changing the title of it because, I don't know, I'm in some dictatorship where I want to say remove all the books about otters. What endpoint would I register here? Yeah. Patch is update. Would you post data or would you have no data in a patch? Let's see if this, what's your name?
Sophia.
Let's see if Sophia really understands this stuff. So remember, get has no data in the request, right? Post has data. What do you think about update?
I mean, you're updating it with something. You can't update without data, so there's got to be data.
Exactly right, Sophia. So patches also typically have data in the body because you need the new content to update the old content with.
Can you just do a patch for post?
Oh, that's actually a very good question. Not that I'm surprised that you asked a good question, but yeah, so the question was like, I think what you're asking is why could this just always be a patch? Because then is that what you're saying? All the other way around. Oh, okay, all the other way around. So why is it a good question? Because of something called REST. Okay. So REST is this idea. Okay. REST is this idea that actually I could do whatever I want in my code, right? I mean, that's why being a programmer is so amazing. I could make the post app books function delete all books. Couldn't I? Whatever logic I want to do in here, it's just the request type, but what I actually do is up to me. In fact, most engineers are bad engineers, and most engineers write bad code, and most code that's written is bad, and most code doesn't adhere to these rules. I'm getting ahead of myself. I can do whatever I want in these functions. But if everyone keeps doing whatever they want, like protocols breaking down, the web will probably break down. Or think of it simpler, if you're all working in a software engineering team and this third of the room is working on the books database library, this middle room is working on the books front-end user interface web page, and this you're all working on the books testing team. Do you have to want to pick up the phone and call these guys every time you want to make an endpoint because you want to know like what's the name of the API that I should call to update a book? Right? That's annoying. So what engineers did, we got together and we said, no, this is getting out of control. Like this guy is like deleting books at the post request and she's patching books all the time because she doesn't want to write post ever. It became a bit of a nightmare. So we said, let's come up with a set of agreements and on how these things should be declared and what they should do typically. And that was called REST. And a RESTful API is an API that adheres to these rules. Now, they are completely unenforceable rules. It's up to you to write your endpoint in a way that reflects these rules. Most software backend systems will try and write RESTful APIs. Most will fail. But somewhere on the way, we're in a better place for doing this. And what REST is really is a set of rules. Apparently, that's the only slide on it. Oh my God, that fair work REST break rules. I mean, that's quite funny. Anyway, RESTful API rules. Let's see, what's a nice resource that I've found? But see how these are being called best practices? REST is a set of best practices, a set of rules for how you should build your endpoints. And so, in RESTful rules, you should always accept and respond with JSON. Don't throw different formats and instead of using curly braces, I'm using different braces. That's a nightmare, right? Okay, this is interesting. Even how we name the endpoint routes is important. This is one of the really typical RESTful rules. So in the books example or the otters example, if you want to get back a list of all the otters, you could actually, so if I told you I'm making an otters and API that's RESTful, and you want to get back a list of all the otters in my database, if you know the RESTful set of rules, you will actually know exactly what endpoint to hit. And it will be my URL / otters, that's it. Now, why is this rule important? Because otherwise, should you type get otters, get all otters, get list of otters, query database for otters? Do you see what I'm saying? So part of the RESTful rules is we say just use the noun of the thing. That's why it was called books, otters. There's even rules around the plurality. So should you call otter or otters? Well, without the RESTful rules, we don't know. I'm pretty sure what you do, and this is going to test my understanding. I don't know, apparently this link isn't working, but I think for getting all, you do have the plural, but for posting or updating, you don't have the plural. Let's have a look. Was I right? I mean, this is an AI response, so who knows, but for plural nouns of collection endpoints, use books, not book, so that's right. But for getting use the plural form with an ID to reference a specific item. So if I want to get book 1 from the books, it's books / the ID. But I'm pretty sure, yeah, so for, well, okay, keep it consistent, of course. But I thought it was, no, it's always plural, basically, yeah. So it's just these rules on how to format these URLs. Okay. All right, what did I skip? We spoke about, oh yeah, there's a bunch of other ones. We spoke about this. See, this is what I mean. Like, I've never used like trace, connect. You'll never use these. I mean, I don't know. It depends the type of work that you do. They're very uncommon. This is a nice little reference table for, should there be data in the body? Should there be data be in the request? Should there be data at all? But it becomes very intuitive. I can say that. Skip that. We spoke about APIs. There's a little cycle for what happens when we load an API via HTTP. Of course, we request information, we get data. This is a separate request. We get extra data. That might be a JSON object that comes back. We might submit data, right? You get back your response. What's important to know with HTTP is you always have a request and you always have a response, even if you do nothing with it. You want to know, did the request work? We spoke about REST. We can make requests in code. I guess we'll talk about that on, is it Thursday? Yep. There's lots and lots and lots of libraries to make request code in JavaScript. Apparently the one we're going to be using is sync request curl, which is a new one for me, but we'll have a look at that. We'll do that next week. What else is left? Just a few slides. Okay, yeah, this is all I wanted to talk about. And we're done, I promise. I'll be on time. I said there's always a request and there's always a response. Always. And in the responses, we have response codes. And all the code tells us is broadly what happened with that request. So if requests worked successfully, you always get back a 200 series response code. You've probably seen it before. 200 is OK. And there's the X's. There's a whole series of rules around 200, 201, which I think means OK and then something updated or something. The one you'll see lots in your life is 400 series codes because that means something went wrong. Very common, right? So let's go back to Insomnia. Let's say I make a request for an endpoint that doesn't exist. This is a 400 series code. It's a 404. It says it right here. If the endpoint was there, okay, I guess am I in books now? Whatever. If it was there, you'd see it say 200. There's hundreds of these response codes. The big ones are 200 is OK. 201 I think is OK with an update. Where's my fact checker? Can someone remind me what 201 is? 404 means not found. There could be many different types of error codes. 500 series codes are kind of a sigh of relief for the programmer. What is that?
201's correct.
Okay, that was so strange, right? Okay, anyway, I don't know if you couldn't hear, something just like took off. This place. 200, yeah, so 201 means that worked okay and something changed. 200 means that was okay. Yeah, 500 series codes is like, there was an error, well, it's not good, but it typically means the error is at the server, not the code running on the server. So if you're the server developer, you can be like, whew, and it's someone else's problem, but it's all our problems. So yeah, it could mean there's a networking error, didn't even reach the server, something went wrong before it got to the server. They all mean something. There's so many of these codes. What's the other famous one? No, it's teapot. 418 means I am a teapot. It's in the formal definition of error codes under RFC 2324 and RFC 7168. It was added by the International something as an April Fool's joke. And if you get back the error code 418, it literally means I'm a teapot. I don't know, I guess we're all, anyway. This was all built by like nerds, right? So, all right, that's the content. You'll be using all of this in iteration 2. And you can wrap iteration 1 in a HTTP server as well. As you can tell by what I'm saying, I'm reading this off the slide because I don't want to misdirect anyone. In iteration 1, it's not too sophisticated. In iteration 2, it's much more sophisticated. Okay, this is some of the most important software engineering content you will do at UNSW. When you go off to work, hopefully as a software engineer one day in industry, most systems are running on this framework. They should be. You will have interview questions for your junior job and they will say, Sophia, what does it mean to write a RESTful endpoint? And most USID software students will get it wrong. But you guys will get it right. And you'll say, well, okay, I can talk about RESTful. It's a series of rules that we established, an agreement on how we should formulate endpoints for consistency, readability, reliability, so that I can trust my endpoint teams on how I should format my requests. And they will say, Sophia, you got the job. Okay? But if you go there and you say waffle, 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 and ChatGPT told you this and Claude, you don't know what you're talking about. Oh yeah, this is also kind of interesting. If you guys got to go, you can go. I was actually just reading an article about this. So, what's the company that handle all the payments? Square. Square are API back compatible for like 15 years or something. And the point is sometimes you release new versions of your API, like when I'm a massive millionaire and my Otter API system is sort of really large. You might need to version your endpoints so that people using old versions of my code can rely on using it and they don't have to update their applications. So actually what you might want to do is make your endpoints /v1/ everything so that later in the future if you want to update stuff, you can update it, you can change how your endpoints work and what they're named, but it won't break your legacy users. This is important for Google, for Meta, for really large tech companies. If most software, you're working for a startup, a company, you're building the next Facebook, you've got a team building the API, you've got a team building the front end. If you change something in the API, you pick up the phone to your mate and you say, hey, you got to rename these URLs, and they update the URLs. It's not a big problem. But if you're building APIs used by the public, let's say that you're the Bureau of Meteorology, maybe this is more important and you should think about versioning. I don't even know what token encoding is. It's probably interesting and correct and relevant. I've just never actually heard of it. A token is generally stringified for sitting over HTTP. Everything over HTTP needs to be stringified. That's true. That's also very interesting. So anytime you even post data to a request, and you know how we're posting JSON, there's no such idea of sending JSON over the network. It's all text, it's all string. So something has to stringify it, it's called, got a great name. And then that gets sent over, then something else has to turn that into zeros and ones and part of the HTTP protocol, blah, 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 blah. I think this is talking about how we encode and decode the URLs into JSON. It's all done for you. Typically, you don't have to deal with this very much. And there's a feedback form. I have no idea if this is just Shaveen's typical feedback form or how this works, but I'm sure if you scan it and you say Jake was amazing, he'll read that and that'll be great too. Anyway, that was a lecture. Sorry if the pacing was a bit off at times. I hope you enjoyed. I'll do the request stuff in the next lecture on Thursday. And basically, this is just the start. There's so much we want to do. I've written thousands of endpoints for systems used by a few people. In fact, anytime you use, do you remember DCC from 1511? Anytime you use DCC help, that hidden endpoint that I wrote the code of, anyone done algos 3121? No, you're all too early in your programs, I suppose. No, algos 3121. So has anyone used formative in a different course? It's a web system used by some courses of CSC. I built most of that. All those endpoints, there's thousands and thousands of endpoints. You'll be writing this code a lot. So anyway, thanks for the lecture. Have fun. Tell your friends to come on Thursday and we'll have more fun. Thank you.